Hey, what's up, everyone? Welcome, and thank you guys so much for joining us for another great video meetup today, sponsored by Radware. Today, we're going to be learning all about how to get control back over your multi-cloud environment. For more on this, we have a great panel of experts, including an IT pro from the Spiceworks community, as well as an expert from Radware. So without further ado, let's go ahead and kick things off with a round of introductions. Let's go ahead and welcome our guests in. Coming to us first from the Spiceworks community, we'd like to welcome Mr. Xander Langford. Xander, how's it going today?
Not bad, not bad. Yourself?
Always a pleasure to have you on, Xander. It's been a while. It's been too long. Hopefully,
Yeah.
but excited to be working with you again. Xander, for those who've not met you before, do you mind telling us a little about yourself and what you do?
So I'm a systems administrator within the recruitment industry. Currently looking after a multinational kind of group of different recruitment agents. So
All right, wonderful. And where are you based out of, Xander?
currently based in Glasgow.
Glasgow. All right, welcome. Well, thank you so much for joining us today, Xander. We're excited to hear from you. Our next panelist representing Radware, everyone please welcome Mr. Dror Zelber. Dror, welcome to the show. How's it going?
It's going fine. Thank you so much. I appreciate it. I'm glad to be here.
All right, wonderful. And just as a heads up to our audience today, we are working through Dror's, to play it safe for you guys, the audience. Dror is dialed in through his cell phone, so you may see a slight sync issue with his video, but that's to be expected. So, but we're excited to have Dror on, representing Radware. Dror, do you mind telling us a little bit about yourself and what you do for Radware?
Sure. So my name is Dror Zelber. I am located in Israel, and I am the VP of Application Delivery Controllers products within Radware, product management. Application delivery being anything and everything that relates to load balancing, SSL offload, SSL-related functionality, cloud-related functionality, be it on top of boxes or virtual cloud, private cloud, whatever. So all of it is under my responsibility as product management.
All right, wonderful. And I see you have a wonderful set of guitars and what might be a lute or something in the background. Do you want to tell us a little about what you got in the background? You said you referred to them as your babies before the show. Can you introduce them?
Yeah. Yes, this is just a small part of my guitars collection. So back here we have, for those of you who are familiar or are interested in guitars, we have a Gibson Les Paul from 2006. For those of you who are interested, this is very important, stating the year, as well as a, let's see if I can sort of point it out, a Fender Jaguar reissue 62. And there down at the button is my new baby, which is a Gibson 335, ES335. And in the closet next to me, I have a few more. So yeah, I play in a band, and this is, this is for living and this is for soul.
Wonderful. Well, thank you so much for joining us today, Dror. We're definitely excited to hear from you. Before we go any further, a couple things I did want to point out. If you do have any questions for our panel today, make sure to get those questions into Q&A. We'll be taking any questions that you guys have later on in the show. Also, make sure to check out, we got a ton of great resources from Radware in that resource list if you guys are interested in learning a little bit more about the solution. And wanted to give a special shout out to chat, some of our favorite folks in there like Kip and B. Beckers. Of course, if you do participate in chat, we ask that you do adhere to our community guidelines and make sure that everybody's having a positive and professional experience in today's event. All right, well, Dror, I think to kind of help introduce what we're going to be talking today, I know you prepared some slides, so if you don't mind just kind of sharing your screen and just kind of walking us through what we're going to be talking about today.
So basically what we wanted to cover today is, as the title of the presentation says, delivering applications in the cloud and multi-cloud era. Basically what we want to cover today is what are things and trends and feedbacks that we are receiving from our own clientele, as well as from various research groups, as well as obviously seeing in the market in general, in terms of trends that accompanying us and our customers in their need and their capabilities in delivering applications. We will go through what we see in terms of the trend of deploying applications in cloud and specifically multi-cloud. We will want to review shortly what are the advantages that our customers telling us that they see in going to the cloud, and then obviously review the challenges that our customers are seeing as well as we obviously see when transitioning to the cloud, and end up with a brief sort of introduction to a solution that we at Radware offer, which is very much tailored to delivering applications and delivering application delivery controllers, ADCs, in the cloud, in a multi-cloud sort of arrangement. So that's basically sort of the path by which I will want all of us to travel in. And so with no further ado, let's just start and see basically what are the, I would say, the motivations for businesses, for organizations to go to cloud eventually. So I think that the main motivation is basically our businesses in the digital era. So customers really the customer experience and the digital business models are the ones who are driving all of our enterprise IT customers' initiatives currently. I think that just providing a few examples, such as many businesses are seeing more and more demand to access their services, applications, capabilities from online. It could be a PC, a tablet, but mostly even a mobile phone, rather than obviously meeting face-to-face a representative of the organization, and even speaking through the phone. So you could get examples, for instance, from your banking account. You would definitely now, all of us, I think, are using by now mobile applications to access our banking account, review information, perform operations. And the last thing I think that the most people here would agree with me is that we want to step into a bank branch and talk to a representative there. But that obviously, while it has a lot of advantages, it basically introduces a lot of work for businesses, because businesses need to set themselves up to be able to perform well and be competitive enough in the digital era. We called it the digital transformation. The consumers themselves, our clients, all of us, are rating products and services based on their digital experience. By rating and digital experience, we could give a very simple example, as in, again, banking application. As soon as my banking application does not perform the way that I would expect it to, be it because it's very slow at a certain point in time, or that it doesn't provide all the necessary operations for me the way I see it, I am being very much annoyed, to say the least, not just with the application, but with the organization, the enterprises I'm working with, be it a bank or a government agency or a retailer or whatever. And so, if we basically look at a few excerpts from be it customers or analyst groups. So for instance, the top one coming from Salesforce stats, and I'll read it out, that of consumers, 76% of the consumers think that companies should understand their expectations and needs. And that obviously is always true, but when it comes to digital experience and digital transformation, this basically amplifies. From IDC, 85% of enterprise decision makers, the CIOs, the CEOs, the CMOs, whoever, they say that they have a time frame of around 2 years to make significant inroads into digital transformation, or they will fall behind the competitors. This is big, and obviously suffer financially. This is something that is repeatedly, we hear that repeatedly from our customers. Our customers are now looking into being able to compete in the digital world and be able to obviously offer whatever their consumers, clients need. So that basically takes us to sort of a journey that organizations eventually need to do, and some of them have done, some of them are in the sort of the midst of doing. In order for us to understand why eventually cloud, public cloud, multi-cloud as a as a cost-effective paradigm for organizations to choose, I thought that it will be, beneficial for all of us to understand where we were, some of us where we are, and where we're headed to, so that we will have a common ground of basically terminology, so to speak, to be able to identify and agree on the next ideas that I will present in this next slide. So, to a large degree, many of the organizations are still deploying applications and networking equipment in what we in Radware call their own private data center. Some call it the legacy data center already. Private data centers being predominantly built off of proprietary boxes. So switches, routers, yes, layer 4 to layer 7 services such as ADC or security devices, boxes coming from Radware or from anybody else. I think that organizations have learned years ago that the disadvantages or the challenges by deploying private data centers are that those are, for the most part, rigid. I think that anybody who is deployed or is deploying a box for anything knows that it's quite challenging to upgrade the box or to replace a box. A box is something physical that needs to travel from one location to the other. In order to get there, it needs to clear customs, it needs to be in your building, you need to set it up, et cetera, it takes a lot of time. If a box is limited, or if you have not foreseen the capacity of a box that you thought you would need, all of a sudden you need to replace a box. In some cases, it's nice to upgrade, but in some cases you need to replace it, and the thing is rigid. The business, for quite a few years already, does not allow organizations, our customers, to be as slow as a private data center, a legacy data center, forces them to be. They need to be much more agile. And so many of our customers are either now moving to or have started already years ago to move to what we call the virtualization automation. Adopting more virtualization and automation around their data centers so that they can eventually be more agile, faster, and leaner, so to speak, in order to serve the business and be able to spin up applications, services, fix stuff, upgrade stuff, improve stuff, obviously much quicker and, as best as they can be, more cost effective. So the likes of various private clouds, be it OpenStack related, VMware technologies, Cisco technologies, doing a lot on automation, which, by the way, Radware was a pioneer, at least in the layer 4 to layer 7 services, automation with our own proprietary automation capabilities, allowing to spin up services very quickly, to add up functionality capabilities, hook up ADCs into a networking diagram very quickly. All those types of things definitely improve the overall agility of an organization and allow the organization to move, so to speak, forward with the digitization paradigm. However, eventually, we now see that even that is by itself not enough. And customers, in order for them to be extremely cost effective, again, everybody's trying to improve its cost effectiveness and be obviously as efficient and as effective as possible. And so I think what customers are telling us is that it's inevitable for them to start adopting more cloud capabilities and technologies, so public clouds as well, AWS, Azure, Google, whatnot. In some cases, adopt also or alongside private cloud technologies, be it OpenStack or VMware related or Cisco related, and there are obviously additional private cloud technologies as well. And in some cases, we now see customers, I would say, experimenting, and some of them are actually deploying their workloads and applications in a multi-cloud environment. I would like to state a few things about that from my experience. I've been in the networking industry for more than 25 years, and I've been in Radware for 6 years almost. When I started off with Radware around 6 years ago, the discussion around adopting cloud technologies, be it private and definitely public, was still, I think, at the beginning. We saw a lot of CTO departments and sort of high-level technology departments being interested, sort of playing or experimenting, however you want to call it, with various cloud technologies. But for a couple of years, we at Radware did not see true, I would say, production scale, large scale deployments of cloud, and actually an organization which is reliant on cloud, be it private or public. For the last 18 months, I would say, give or take, what we see is true adoption of cloud technologies. Again, be it just private or just public or a mix of them, we see true adoption. When I say true, I refer to when I am in meetings with customers, I see the procurement department, I see the DevOps department, I see application developers and business owners, and I see the IT department. All of those representatives are sitting alongside myself in a room and are very much interested in the various angles and aspects of the solution that I propose, which to me obviously broadcasts or says, this is serious business. These guys are interested truly in cloud. It's not just and obviously, I don't want to obviously offend anybody, but in many cases, if the CTO department is interested, it's very nice. You know, we have a very nice discussion, but in many cases, it does not eventually lead to a large-scale purchase, which, you know, I have to make a living off of. Nowadays, it's completely different. I cannot obviously state names of customers yet, but we have tons of customers who are actually deploying in cloud. So this is a trend which is happening, not anymore something theoretical. And the second thing that I wanted to sort of try and hopefully agree with everybody here is on the term multi-cloud. Oftentimes, people refer to multi-cloud as in, yes, my organization deploys stuff in both AWS and Azure and Google and OpenStack at the same time, like 3, 4, 5, 6 cloud environments. This is multi-cloud. Well, it is multi-cloud, but it's not the only thing that we can call multi-cloud. From my perspective, as soon as you, the organization, are deploying workloads in 2 environments, and even more so, the first environment be your private legacy data center, and the other one is whatever cloud that you are now sort of focusing on, you're in the multi-cloud environment. Whether you like it or not, you're in a multi-cloud environment. Customers who are already deploying applications and their business is running and making money, those customers, to the most part, I have not seen a single one who can decide to migrate an entire private data center to an entire different cloud in a day. Not in a day, not in a week, not in a quarter, in most cases, not even in a year. It takes a lot of time. And that transition time, which we call cloud transition, entails and forces the customer, the organization, to be in a multi-cloud environment. So at least 2 environments, you're in a multi-cloud thing. Okay, let's check the advantages of multi-cloud as, you know, we see them obviously at Radware and also as they are reported to us by our customers to sort of have a common background, a common agreement on why adopting cloud and multi-cloud is obviously beneficial for organizations in the era of digital transformation. So there are many advantages, obviously. I sort of thought that these ones resonate very well from a business perspective, from a technical perspective, from a cost perspective. The first one is the freedom to select your most cost-effective environment. When you select your private legacy data center, obviously at the day of selection, you select what you thought was most adequate for you. But time passes by, and in many cases, it's not up to date or optimal anymore, and you have to sort of chase and run after it. You have to maintain it. It costs a lot of money. With public cloud, to the most part, you can decide if your technology and if your vendors support it, and we'll talk about it in the next couple of slides. You can decide to move from one cloud to the other, I would say easier than it would have happened if you would stay with your legacy data center. And in many cases, customers believe that is the case. It could be the case, again, as long as your vendors support this. So that's one advantage. And obviously, trying as much as you can to avoid vendor lockdown, etc. I don't think that anybody can avoid 100% vendor lockdown, but everybody's trying to optimize, sort of be as less as vendor locked as possible. Increased reliability, to the most part, with public clouds or with private clouds, but those that are maintained by other professional sort of organizations, or if you have your own professional organization. But mostly public clouds, they're very reliable. The reliability, the accountability, and the liability relies or is put on the cloud provider. So a lot of infrastructure in my language, layer 2, layer 3, in some cases even layer 4, is provided by the cloud provider, and it's his job, it's his responsibility to maintain that and provide 24/7 availability. So a lot of the burden is taken off of you, the organization, and your IT teams, etc., and it's put on the cloud provider. And you pay for it, obviously, but it's a win-win situation. And obviously, there's a lot of advantages when it comes to continuous integration, continuous development, CI/CD. You can automate application development, deployment, a lot of the cloud providers provide very nice DevOps tools, infrastructures, bits and pieces that you can, as an organization, build or hire somebody to build your own sort of DevOps environment and create, the agility and the flexibility that you so much need in a digital world. So those are the main advantages that we saw. Obviously, again, I would say there's many other advantages, and some of them are more specific to one organization and less to another, but those are the key ones. A thing that is not mentioned in the presentation, which I think now is very important to mention, when it comes to digital transformation, in many cases, not many cases, but in some cases, we were asked by customers or even by analysts, guys, how often would an organization, once deployed an application, would then change that application, upgrade it, fix it, improve it, or more so, how often would an organization spin up new applications or destroy existing ones? And the answer is, up till, let's say, a year and a half ago, maybe some of you would say, though you're mistaking, up to even 2 years ago, it would be once a year, once a half a year. So the development cycle of an application would be somewhere around 6 months, 8 months, 1 year for an organization, a business application I'm talking about. These days, there are surveys by IDC, by Gartner, and we see that from our customers. And I urge you, if you're a little bit sort of on the not believe side, go and check those surveys. Organizations are deploying applications as agile as once a day. And we truly have customers, not many, but we do have customers, mainly in the news and the financial news department, who are deploying applications on a daily basis. An application could be as simple as a web page, which is very relevant today and tomorrow, and the next day will not be. There will be another application relevant. Every sort of web page with whatever ticker or news is an application. You have to spin it up. You have to provide it with an IP and with a load balancing service and protect it, et cetera, et cetera. Organizations are now spinning up, deleting, changing, upgrading, updating applications much more rapidly and much more frequently than before. And so this is digital transformation. And so, this entails that organizations be as flexible, as agile, as fast, and obviously as cost effective as possible.
So just to add in there, the company I currently work for and the previous company, when we were deploying test applications, we would be deploying every 20 minutes or so. And then when it came to patching and bug fixing, we were deploying every couple of hours. And then you would get a period of quiet until the next kind of deployment schedule happened. But as you're saying, with the daily deployments, it's certainly something that a kind of orchestration side of things would have a massive advantage in.
Excellent. Thanks for the feedback. It just goes to show that the business is becoming, I think in a layman's language, we could say that the business is becoming hectic as hell, pardon my French. And I think that a lot of the burden is put on the shoulders of the professional people, the IT department and the IT team, the security team, with the legacy methods such as boxes and physical ports and cables, etc. It becomes almost impossible to maintain such business, to deploy an application every 20 minutes or even every 24 hours, right? And so, With public cloud, to the most part, a lot of it, not all of it, a lot of it is being solved, and a lot of the other things that are not solved natively by a cloud provider could be solved by vendors. So with that, let's review the challenges, because surprisingly enough, when you transition to another paradigm, it doesn't necessarily say that all of your problems in the world are being solved. In many cases, they just change, and we need to learn about those challenges, acknowledge them, and see how can we resolve them. So the first challenge is cost structure, right? Public cloud cost is not free of charge. For anybody and everybody who thinks that public cloud, I've heard customers at the beginning of my history saying, you know, we're moving to this and that public cloud, we're putting all of our workloads, and the ADC is free of charge. The web application firewall costs very little. It's likely free of charge. I urge you, if you think still so, do your own math. Calculate from the pricing of whatever public cloud. I won't mention names deliberately, but just go to any public cloud that you think. Look for the price of an ADC. You would see that it costs 0.000 cents an hour. And then if you multiply it by the seconds and by the minutes, by the days, by the hours, etc., and you get to a year, and then you calculate how much does it cost for a layer 4 and for a layer 7 and for SSL and for TCP connections, etc., you'll find out that it by all means is not free of charge and even not cheap. So the cost structure, yes, if you own a data center of your own, there's definitely a cost structure there. But if you go to the public cloud, you have to understand and know exactly what is the cost structure for each and every sort of infrastructure that you're using, service or product or whatever you're using, to make sure that you're making the right decisions. Transforming from one cloud to the other, right? From, let's say, just for the sake of example, transforming from AWS to Azure. In some cases, it's required. And again, from my experience for the last 24 months, we've seen customers who have been experimenting with one cloud only to understand after 3 to 6 months usually that this cloud is not necessarily the right thing for them. It could be from an infrastructure perspective because that cloud does not necessarily provide the right infrastructure, the right API, the right performance. Or from a business perspective, the payment cost, the structure, the cost itself is not what they expected, what they were told. And so now that they're smarter, our customers, they're looking at a different cloud and they know what questions to ask, what pitfalls not to fall into, and eventually they decide that they want to move to another cloud. Okay, can you do that as easily and sort of, almost without an extra cost or without paying taxes, so to speak? No, because whatever works in one cloud does not necessarily, or at all doesn't work in another cloud. APIs, infrastructure, performance of, the certain so-called functionality that you thought you have in both clouds, and it goes on. Even trying to standardize on Kubernetes, which is sort of what Java used to be back at the days, write once, deploy anywhere. Even Kubernetes is not as, I would say, proliferant or identical in each and every public cloud, and you end up consuming a lot of the proprietary infrastructure from that cloud provider. So cost structure could definitely be something that if you're not calculating your steps correctly, and if you're not understanding what you're doing, this could get back at you. I would sort of provide you a hint that with selecting the right vendor that can provide you with this, I would say, transparency is the word I was looking for. In between clouds, you can obviously minimize the risk and minimize the cost structure that is usually entailed when transitioning in between clouds. Now, the last thing I'd say about this is that many customers are saying, well, or many of you might be saying, why should I transition to the cloud? I check my cloud very nicely, and then obviously I fixed on something. The answer to that would be that there are many customers who are now at the phase of experimenting. They're not, by all means, stupid or unexperienced. They're very much experienced and they're very much smart, and they have very nice and very proficient IT teams. It's just that cloud is a little different, or very much different in some cases. And the range of error when thinking that this cloud, this technology, this set of capabilities is the right thing for you could be large. And you might end up understanding that one cloud that you thought is good for you is not, and you have to transition. And so this happens to our customers. So that's the first sort of challenge, cost structure, and everybody thinks of cost. You know, the CIOs, the CEOs, they think of cost. Experience and ownership is the second challenge. So multi-cloud familiarity. Think about it. With your own legacy data centers, you knew anything and everything in your infrastructure, in your networking, in your deployments, in the applications and the various boxes that you maintain. You gained that experience. You made sure that nobody would replace the vendors you're working with, at least not less than 3 to 5 to 10 years. And you needed a single IT team, so to speak, to manage the infrastructure. What happens if your organization decides to transition to a few other clouds, let alone obviously adopt a multi-cloud? All of a sudden, there are technologies, capabilities, networkings, restrictions coming from Azure, which definitely will be different from the same technologies, restrictions, networking capabilities, disk capabilities on AWS or on Google or on any other cloud. So all of a sudden, if your organization and if you, the IT people, are deciding that you want to use the native capabilities coming from that public cloud, the native infrastructure, the native layer 4 to layer 7 services, you might find yourself ending up with needing to know 2, 3, 4, 5 complete different technologies at the same time. And so the scale of familiarity increases, dramatically. What does it entail on you? It's either you work 5 times harder, or that your organization now needs to hire more people. But here's the surprising truth and news. Organizations are trying to now cut in terms of the resources that they hire or spend, and they want to be much more agile and cost effective. So this is one challenge. The second challenge that in many cases organizations don't necessarily understand, but IT teams and networking teams definitely understand very well, is that to a large degree, not to the entire degree, but to a large degree, you, the organization, you don't own the infrastructure anymore. With public clouds, for instance, you don't own layer 2 for the most part, right? And so if you were used to deploying your networking diagram where you control the VLANs or you control MAC addresses or you do various tweaks on top of layer 2 and in some degree layer 3, all of a sudden in public cloud, it's either completely impossible or that you have to pay tons of money in order to have your own complete private network, including layer 2 capabilities that you can control those. Organizations not necessarily understanding that, IT departments definitely do. We have customers, I can tell you, we have customers who were, the IT department was forced by your organization to move or try to deploy stuff on, let's say, on one of the public clouds, where the IT department then, found themselves trying to understand how can they do the same things they've done, tweaking layer 2 and VLANs, etc., now in public clouds. Again, a challenge. Everything is solvable, obviously, but it's a challenge.
And a lot of the times with that, even if you do have access to the layer 2 and it costs something, it's obfuscated away to a point where you can barely find it.
Right. And this is a very, very, very important statement that you said. We are seeing customers where, and I'll talk about it, for instance, in dashboards and visibility. It's a new sort of buzzword, the visibility. Public clouds, I would say, provide a lot of infrastructure, almost everything that you need in terms of the atomic building blocks. But go figure out where those are and how to sort of consolidate all of it to a solution, sort of a one-stop shop solution. That's difficult. Public clouds don't necessarily help you. If you pay for it, they will help you. If you hire a third party, he will do that for you. Again, cost. So at least from that perspective, familiarity and the ownership and, good luck trying to find out how to do stuff is definitely are also challenges. Moving on, consistency and standardization. So public clouds, if you move on to multiple cloud sort of deployment, again, public clouds introduce inconsistency because of the different native technologies, right? So, for instance, Azure's APIs, while they offer, for instance, layer 3 APIs or telemetrics APIs, those are completely different than the AWS APIs. And I can guarantee to you, I think, what I'm saying is obviously you know that public cloud vendors will make sure that their APIs are somewhat very much different from one another so that they can obviously sort of, again, lock you down once you selected them and make it very, very difficult for you to move to the other cloud. And the same thing goes with almost any other technology that they introduce. I may repeat myself with the next slide, but I want to say, for instance, with layer 4 to layer 7 services, the inconsistency could come in between. So, for instance, if you have an ADC coming from Azure, native ADC from Azure, and a native ADC from AWS or from Google, who says that the same functionality that you were used to getting in your own private data center by one of the vendors of ADC would be provided within any of those cloud providers? Who said that the way to consume that certain functionality would be the same? Who said that it will be easy as it was in the data center, or even difficult? Who said that the performance of a certain service that you were used to consuming in your own private data center would be the same as the one in the cloud? Who said that the performance will be the same in between the clouds, right? And so all of a sudden you see that inconsistency on networking, on services, on APIs in general is something which is a challenge. How do you deploy the same application across clouds? Because across clouds means you can save the cost, you can basically split up the risk, right? But then the burden is on the IT departments to make sure that the same feature set is introduced, that it's easy to consume this feature set, that the performance is actually the same, but it doesn't necessarily being guaranteed by the cloud vendors themselves. Lack of standardization, again, sort of I would say a byproduct of inconsistency. Same examples, APIs, not necessarily the same. In some cases, one supports a certain standard like HTTP2 or HTTP3, or even in HTTP2, there is just a gateway mode or a full proxy mode, et cetera, and et cetera, and et cetera, IPv6, to what degree. One cloud can support this, the other cannot, maybe. And all of a sudden, if you wanted to standardize on something in one cloud and you found it, you might not find it in another cloud, or not exactly the same. Again, a challenge. The challenges, I just want to reiterate, are, to the most part, by selecting or trying to select the native cloud infrastructure and services. Okay, visibility. Visibility is something extremely important. I think that, again, as I've stated, I've been many years in the networking industry, all across switches, routers, whatever. Visibility, to the most part, within the networking industry, and Radware is part of it, was something which is sort of a neglected child, I would say. To the most part, we would use Wiresharks or command line or whatnot to understand what's going on with the service from a networking perspective. Some cases we were introduced with, I would say, generated visibility or dashboard capabilities, but to the most part, those were not necessarily up to date. Today, visibility is king. Every one of our customers is, before even he knows that we're doing visibility or sees the visibility capabilities we provide, every customer asks for specific visibility capabilities and asks if we provide those, we're about to provide that in a reasonable time frame. Visibility is king. The thing with visibility is that while, as I stated before, public clouds, all of the ones that you can think of, they provide the building blocks, to create eventually a visibility solution. So they provide, for instance, the Kibanas or the Splunks, and they provide the databases, and they provide capabilities or APIs to extract information, etc. But eventually, you, the customer, are responsible to compile all of this into a solution, into something that you click on, that opens the browser, and you look at dashboards and charts and numbers and clicking buttons to dive more deeply and perform activities and actions that are about root cause analysis and obviously fixing. So you're entitled, or it's your responsibility to compile all of those building blocks that a cloud provider offers you into a solution. Obviously, if you go to the professional services of a certain cloud provider and ask them for a tailored solution, yes, for money, everybody will do it. But it's not. It might definitely not be as cost effective as selecting a, a single pane of glass solution coming from a vendor. And then again, all of the other challenges, such as familiarity, such as standardization and consistency, all of these kick in. Also, visibility. Who says that all of the infrastructures that are existing in one cloud are existent in the other cloud at the same level, at the same rate, at the same price, with the same capabilities of tailoring everything and creating a single solution across all of the clouds? If not, then again, all of these challenges that we've just talked about before resonate again. Xander, do you have anything that you would want to add on that?
To be honest, the visibility across multiple clouds is something that I've struggled with in the past. Being deployed in multiple clouds simultaneously, at times even with the same application, and having to use different tools. To have it all in one place would be a really interesting situation, actually a bit of a breath of fresh air. In the case of measuring application performance, say you have an application which is deployed in your legacy data center, to use that term, and also say in Azure, to use that as an example. How would you measure the difference in performance between, say, an API call to both of those?
Right. So this is again very much challenging. This one, as well as how will you eventually understand the latency of an application residing in AWS or residing in your data center, in your private data center, et cetera, and et cetera. So basically what it means that you either eventually end up managing or taking control over a few technologies coming from public clouds and your legacy data center to ensure that the measurements that you make, the APIs you're using, whatever graphical tools that you're using are either identical or are providing eventually the same results, because it's not you, the IT person or the developer of that IT system, who is looking into that. It's the users, right? And they want sort of a consistency across the system, regardless where it resides or where things are coming from or which infrastructures or building blocks are you using. So that's quite a challenge, for instance. So that's on visibility. Okay. So just to recap, in terms of the challenges that we saw, and I'll be quick of that. Oops, sorry. So cost structure, again, public cloud is not free of charge. Yes, by compute, everybody knows it's not free of charge, but guess what? With networking and layer 4 services, layer 7 services, it's by all means not free of charge. You need to examine the cost structure very, very carefully. Lack of familiarity and the ownership of the infrastructure can create challenges in terms of, now what do we need to do? Do we need to build new IT teams or add more people such that one controls this cloud, one knows that cloud? I still know the legacy data center. Obviously, cost structure, again, reflected here. Ownership, I don't own layer 2. How do I now maintain stuff that I used to do? We have customers that are struggling with this as well. Lack of consistency and standardization, to say that even if you have a service that is running in all of the clouds, it doesn't mean to say that that service is the same in terms of the feature set it provides, in the performance it provides, in the ability to do root cause analysis, etc. Application security, we have not really discussed about that. Let's really quickly dive into that. By application security, I refer, for instance, for example, to the web application firewalls. WAFs. web application firewalls, to the most part, in many cases, in your legacy data center, people would say, well, I'm not sure I need a web application firewall. Everything resides in my data center, and I can secure it, et cetera, et cetera. Obviously, my opinion is it's false, but it was to a large degree, difficult feat to convince customers. When moving to public clouds, multiple or not, public cloud is something which obviously presents a huge challenge in terms of securing your application. So public cloud provider, and you're welcome to check me, does not promise to provide you with a application protection capabilities sort of built into his offering, built into his free of charge, built into his offering. In some cases, the web application firewalls coming from various cloud vendors are subpar, to be honest. In some cases, they don't necessarily provide things like that. So what happens, for instance, if you, and by the way, customers now realize that in public cloud, they definitely need to protect their applications against malicious activities. And web application firewall is one of those, the prime, I would say, application or security measurement by which you protect your applications. But even if Azure offers a web application firewall, or AWS offers a web application firewall, maybe Google offers that, who says that the same functionality resides in all of them? I promise you they don't. Who says that the same performance, right, coming from be it whatever public cloud and the other public cloud is the same? I know it's not. Who says that the manual of operation in terms of root cause analysis, visibility, reacting fast, all of these so-called UX is the same in between all of these clouds? I guarantee it's not. And so if you eventually end up providing 3 different type of technologies to the SOC operating people, security operations center people, telling them, well, guess what? You have 2, 3, 4 type of systems by which you will track our applications and identify if they're being hacked or attacked, and be able to react. They will tell you, well, we're only one person, one team. You need to do a better job. And so this is, again, the challenge is on us, on you guys. So just, to summarize everything, we have, I think, 5 real big challenges when our organizations are deciding to move to cloud and use the native cloud technologies, let alone move to multi-clouds. And someone needs to step in and help with that. And for the remaining time, even less than that, I will want to review very quickly the current Radware solution that is being offered, which I hope that you will agree with me solves all or at least most of these challenges in a, I would say, elegant manner. So what basically Radware is currently focused on, this is Radware new solution, but it basically builds up very, very quickly. We've already released a few releases of this. And so I should state basically that Radware has been in the ADC industry for more than 20 years. We started with virtualization of our own sort of ADC software, ADC boxes, anything in between 7 to 8 years ago already. We've been running on any and every private and public cloud. I just mentioned a few. We had OpenStack. We were pioneers in OpenStack. We were the first one to integrate with Cisco ACI, sort of networking portion of the cloud. VMware, vSphere, NSX, Alcatel, Lucent, and many other sort of private clouds, as well as we're running in Azure and in Amazon AWS and Google, whatnot. Being integrated with various orchestration systems and providing various automation capabilities. Started off with our own proprietary automation capabilities based on our own proprietary products when the likes of Ansible, Puppet and Chef and the other technologies were either at the beginning or not existent. And now we're running with, we've added a very large and robust support for Ansible. And we have customers running with Ansible as well. So that was very nice. And as I stated in the previous slides, automation orchestration, integration with various orchestration systems is very good. But now we need to take a step forward and do something even more holistic. So Altium Cloud Control, as seen in the slide currently, is the name of the solution. It's a software solution that we at Radware are providing. What are the features or capabilities of such a solution? So first thing is that it is a centralized solution with a single ADC technology. The underlying ADC is the Radware ADC called Altion, hence the name Altion Cloud Control, and that Altion runs in any and every relevant deployment environment, I would even say, be it your legacy data center, a private cloud, or a public cloud. So same technology, same Altion, same feature set, same APIs, for the best or for the worst, hopefully you'll think for the best, resides in every cloud that you will want to deploy at the end, which saves you the hustle of understanding how do I work with the this cloud's ADC and the other cloud's ADC, how do I sort of consolidate all of that so that the operators will be able to sort of communicate with a single interface. So with this, it's solved by nature. Obviously, we support multi-cloud, which means that this Altion Cloud Control software controller, wherever you install it, doesn't really matter. You can install it in your private data center, in your basement, in your organization's basement, but still be able to deploy applications in Azure, AWS, Google soon to come, etc. in a single pane of glass. Obviously, networking is something that we need to solve. You guys need to solve it in VPN or MPLS, but this is a problem that will remain forever, I guess, or at least for a long time. But the ability to deploy applications within a single pane of glass exists with this Altion Cloud Control solution. It is very much application oriented, which is extremely important. Why? In the old days, I would say high tech is something which, if it was a year ago, you'd say old days, but this is how it works. In the old days, deploying ADCs, configuring ADCs in order to serve for application would be something that a networking, and I would say even a proficient ADC expert would do. We would not give that activity to say a DevOps or a application owner, developer, let alone to a business person who owns the application. Today, this is completely not true. Today, the DevOps and the application developers, we call them application owners, they ask for this autonomy to be able to spin up an ADC for their application, right? And it's not just about spinning up an ADC for their application without them being experts in ADC, which is what they want. It's also about then the second sort of the day number two, the ability to log into the system and understand what's going on with the scope of applications they own. Are they good? Are they bad? If they're bad, why are they bad? What's going on? What is the latency? Are they being attacked? How can I resolve it fast? How can I sort of point my finger to somebody else and say he's blamed, not myself, which, in an organization, we usually are engaged in this type of political activities. It's not my fault, it's the other person's fault. How do I actually do that? The application people in the DevOps, they want this autonomy, and they don't want the networking person to do that for them. The networking person, all of a sudden, obviously wants to make sure that, yes, I will allow them to do that, but I want to make sure that I confine the application people and not allow them to do catastrophic mistakes or misuse the system. And so there's sort of a balance that needs to happen in between allowing autonomy for the application people and still making sure that networking people can be accountable for the system, for the solution. So for instance, with our interface, with our solution, the application person is a tenant or is a user. He gets a tenant name, a username, he logs into the application. He sees only his application. He sees only the portion of resources he owns or is entitled to. And in order for him to spin up a complete application, the only thing he needs to provide in that interface is the public IP, DNS name. Do you want it with an SSL or not? Do you want a web application firewall deploying on top of it? Basically, that's it. When I say that's it, that means that the controller, our controller itself, basically spins up the new virtual machines, installs the ADCs on top of them, configures the ADCs according to what the application person asked for, makes all the network connections available, and also is responsible for additional stuff that I'll show in a second. And everything is happening under the hood, behind the scenes, completely with no manual intervention and completely without the necessity of an application person knowing what networking is, what an ADC is. So, and obviously then the application person, yeah, go ahead.
Sorry, I was going to say, and I'm assuming that for, say, someone like myself who would have maybe like a dozen or so developers, each working on different things, and they may come together and kind of break apart depending on what they're doing, we can set like ACLs so that for a specific application you can only do a certain amount, or for a specific person you can only do a certain amount.
Yes, by all means, completely true. And we have a layered sort of a degree of operators and administrators, such that you could be an administrator or a manager of a certain team. You can have a manager on top of you who would then have a larger view of the system, of the resources, etc. So yes, by all means, what you said is completely supported by our system. We provide complete auto-scale cluster, which basically means that once you set up your application according to a template which was constructed by the IT administrator, and that template says how many instances can an application of an ADC can an application start with, to how many instances will an application grow automatically, what size of the instance that if you want to add it or reduce it will the instance be, etc., etc. So, but once the application is there, if our controller sees by measuring the load on the application servers themselves and by measuring the load on the ADCs themselves, if our controller sees that another instance of ADC needs to be spun up, it will spin it up automatically, connected to the network, connected to the application, and all of a sudden, instead of 2 instances, you have 3, and so on, until the upper limit that the IT administrator has set, let's say 10 instances. Same thing, vice versa. If the controller understands that the application, which means the instances of ADC, are not overwhelmed, are underutilized, it will then spin down or destroy instances in order for you to save money. Every instance that runs in public cloud consumes a virtual machine or a portion of a virtual machine, and you pay for it, right? You pay for networking, so we're there for you to create a cost-effective solution. So scale out, scale in, completely automatically, but in boundaries that you, the IT teams, can define, such as your application developers will not be able to spin up applications with millions of instances, for instance, completely going out of control, eventually for you and to end up, your organization to end up at the end of the month paying a ridiculous sum that you did not expect. So, everything is for you, the IT people, to control, and for the application people to consume. Everybody thinks he's the owner of things, which obviously is what we want. Auto-discovery of your application servers, but also of your entire environment. As soon as you install our Altium Cloud Control software in the cloud, in Azure, AWS, OpenStack, VMware, our controller, as soon as you provide the basic credentials, such for instance in Azure, you provide username, password, and the secret, sort of, things that you get from Azure, our controller consumes all of your environment configuration automatically and feeds that to itself. Our controller will automatically know at which zones in the Microsoft Azure cloud you're allowed to deploy applications. What type of virtual machines did your organization pay to be able to use? What is your private virtual network? What are the VLANs in the subnet? What are the autoscale sets or autoscale groups that you have already declared and put servers inside or related servers to? We know everything. So you, the IT folks, don't even have to configure stuff anymore manually to a large degree. Our controller will take over your environment in a good way and learn everything automatically. Also, if your application team wants to add a server now to a running application because they think that it needs to scale up, they just need to add that server and that's it. Our controller will understand that this server was added to the application and will add that server under the existing ADC cluster that served that application automatically. So again, no manual innovation. Again, same as if you destroy a server, our controller would understand that and remove that from the ADC cluster. So a lot of automation, still controlled automation to allow you to, to be very agile, very nimble, very fast, but still not go completely out of control. Extensive application-oriented analytics. A picture worth 1,000 words, so I'll just say we provide all sorts and measures of analytics, be it statistics on your application, analytics in terms of the overall delay time. And then if you want to deep dive into transaction by transaction, what was the get and the post, what was the request and the response, who is accessing you, what is the IP of the server that is being accessed, tons of information and ability to remedy and quickly identify what is the root cause analysis of a potential failure or a potential complaint. We provide statistics and deep dive analytics on the SSL that your application is consuming if it does, and also on the web application firewall services if the application consumes those. So anything and everything to allow you, the networking people and the IT and security people, to quickly identify what's going on with the application and be able to either fix it or get back to your manager saying, it's not us, it's somewhere else, which is usually what happens. Security, as I said, we have an integrated WAF capability. By the way, the Radware WAF is ranked #1 at the Gartner Web Application Survey. We support a very compelling pricing model. Unfortunately, time does not allow us to go deeply into that, but it completely changes the way we sell and that the market is used to sell ADC services, not anymore rigid boxes with a rigid throughput that you either need or not need, and you pay for it and that's it. You get to choose whatever throughput, almost whatever throughput you need. You get to choose whatever feature set that you need, almost. You get to choose if you want unlimited number of instances within that throughput or a limited number of instances. It's a subscription-based model paid annually. You can decide to, within the end of the year, you can decide to increase or decrease or completely give it up, or maybe even purchase much, much more. The purchase itself is completely dynamic. It's just a phone call, currently even a phone call, and soon to be even automatic. I purchased 1 gig, I need 2 gig, that's it. The license is there and it's yours. You get a lot of visibility into the usage of the throughput and of the instances, and you can definitely understand what's going on with your application. You can reallocate throughput. By the way that we sell it is that with this Jelly's global elastic license, which means that if you buy a global throughput of 1 gig or 10 gigs, you can deploy that throughput wherever you want. You can deploy all of it in Azure, and then you can decide if you want to take half of it and put it in AWS, and maybe take the second half and put it then in OpenStack, and then replay with it as much as you want without paying us additional cost. You just pay for that, whatever throughput you buy, on an annual basis. And by the way, if your organization is sort of hybrid in between using boxes and virtual instances, we support that as well within the realms of a single global elastic license. So boxes and virtuals, and you can, for instance, if you buy 5 gigabits, you can put 2 gigabits in a box and 3 in the cloud, and then you can take from that box 1 gigabit extra and put it in the cloud, remaining with just 1 gigabit in the box, and you can do whatever combination of mix and matches in between throughput consumption, which is, it's completely break of the legacy methods by which ADCs were sold until now. And we're very much pioneering in that, and we have tons of customers who are supporting that. Now, all of these capabilities, and I just mentioned multi-tenancy as we've spoken with Xander also, all of these capabilities, just to recap, are there to serve you with your challenges in transitioning to cloud and multi-cloud and help you being focused on the advantages rather than on how do we solve the challenges. So for instance, cost structure with global elastic license, hopefully it resonated well for you. The multi-cloud capability, it's the same ADC, same Alteon deployed in many clouds, and basically it's the same interface, it's the same set of capabilities, functionality, same performance, same visibility, a complete one-stop shop solution in terms of visibility and everything, and the web application firewall, again, a single security solution across all clouds. So all of these challenges that we've mentioned previously are, hopefully you will agree with me, being solved with this type of a solution. With that, I basically wrap up the presentation a little bit late, but hopefully that was beneficial for you to stay the extra 5 minutes. And I am free, Xander, if you want to add anything else.
No, it's okay. I said this is a kind of product that we would potentially use with a couple of applications that we have, just because of the way that they're going to have to be put up into the cloud in, say, multiple regions or things like that. So certainly it's been informative and actually quite interesting. So thank you very much.
All right.
Thank you so much. Appreciate it. So,
well, thank you so much, Jor. Thank you, Xander. Big shout out to both of you guys for your time. And also thank you to Radware for sponsoring today's event. Again, make sure to check out the resources that are available if you'd like more information. But until next time, guys, stay safe, keep it spicy. We'll see you back here next time. Bye, everybody.